Let's say you're given this situation here for a head-on collision between two masses, and the question says, consider the elastic collision above between mass A with initial speed VA1 and mass B at rest. What are their final speeds if their masses are the same? To start, we know from last time for an elastic collision, two things are true. One, total momentum is conserved, which means the total momentum before is equal to the total momentum after, and two, that the total kinetic energy is conserved, which means that the kinetic energy before is equal to the kinetic energy after. From last time, applying these two expressions to the situation when mass B is initially at rest yields the following relations: VA2 equal to mass A minus mass B divided by mass A plus mass B times VA1, where VA2 is the final velocity of the mass A after the collision and VA1 is the initial velocity of mass A after the collision. Note, this is assuming that it's a 1D collision, meaning that the collision is in one direction. Similarly, this expression here is derived for the final velocity of mass 2, denoted by VB2. We apply this to our example. We know that mass A is equal to mass B, so we start by applying the equation here, solving for the final velocity of mass 2 after the collision. We know that mass A is equal to mass B. We can replace mass B in the expression with mass A, and if we do that, we get this expression here. Then mass A plus mass A on the denominator is just equal to 2ma. If we plug that in, we can cancel the numerator and denominator, and it just leaves us with this for the final answer. This is the final velocity of the mass after the collision, which means that the final velocity of the B mass is equal to the initial velocity of the A mass, VA1. And so now we can start looking at what the final velocity of mass A will be, which should be denoted by VA2. Sorry about that, guys. So we can start by using the VA2 equation. Since mass A is equal to mass B, we can replace mass A with mass B. And if we do that, we get this. And then the top is just going to be equal to 0. So it yields that the final velocity of mass A is going to be equal to 0. These are results from the collision. From the collision before, the initial velocity of A1 is equal to VA1, and the initial velocity of B1 is equal to 0. After, the final velocity of A2 is equal to 0, and the final velocity of B2 is equal to VA1. This result makes sense since total kinetic energy must be conserved. We see that all the kinetic energy from mass 1 is transferred to mass 2, resulting in the mass A coming to a rest and mass B traveling at the original speed of mass A.